In class activity 12E, sines or cosines. As you read in previous assignment 12E, the following problem was posed and solved by the Chinese mathematician Liu Hui in the Sea Island Mathematical Manual in 263 AD. The unit of length used is the pew, where 1 pew is approximately 2 meters. When surveying a sea island, a surveyor erects 2 vertical poles 1,000 pew apart. The poles are 5 pew tall, and the poles and the island lie in a straight line. When the surveyor walks 123 pew back from the front pole and looks up at the peak of the island from ground level, then the tip of the pole lines up with the peak. Similarly, when the surveyor walks 127 pew back from the rear pole, then the tip of the back pole and the peak of the island line up when observed from ground level. Liu Hui asked the reader to find the height of the island and the distance from the island to the front pole. 1. Use the given information and the picture to the right to draw and label a diagram that may be used to solve the problem. Well, let's scroll down here and make some room. And I'm going to draw first a vertical line. Oops, with the pen. Let's do this again. There we go. And then a horizontal line. Okay. Now I'm going to draw 2 triangles, one inside of the other. So we have, let's see, a smaller triangle right here, and then a larger triangle. There we go. Now let's label this A, and then we'll put B right here. And then vertical line here. And we just do another vertical line right there. And this will be C. That point will be D, E, F, G, and finish with H. Between D and G, this distance here, it's going to be 1,000. Between D and E is 123. So let me just write 123 in here, and that's like that. And then between G and H, it was 127. That. And this, of course, is a right triangle. And the poles, they were what, 5 tall? So that will be a 5. And that's 5. So let's go to the next screen. Objectives for the activity. You will understand the major tools for solving oblique triangles are the law of sines and the law of cosines. You will be able to develop a strategy for solving a given oblique triangle. Next screen, 2. It says devise a strategy for finding the height of the sea island. That is, list in order the sides and angles you will find to determine the height and the method you will use to find each side or angle. Note, there's more than one correct strategy. So here's a way that one strategy could work at least. And I'll just call this, I'll start with I'll call it step 1. Step 1 could be to find EH. And that's by taking DG minus DE plus GH. It's G, okay. We go to step 2. Here, we want to find angles DEC and GHF. Let me write that here. Find angles DEC and GHF. We can elaborate here, which can be done by finding the hypotenuse of each triangle and then using the inverse sine function. So which can be done by finding hypotenuse of each triangle, then we can use the inverse sine function. So using inverse sine function. Step 3. Okay, for step 3, we can find an angle, the angle AEH, by subtracting angle DEC from 180. So we can put, find, that'll work, angle AEH by subtracting angle DEC from 180 degrees. Okay, on to step 4. We can find EAH by subtracting the sum of angles GHF and AEH from 180. So if we continue, we can find EAH by subtracting the sum of angles GHF and there we go, and AEH from 180 degrees. Go on to step 5. Extend the page a bit more. And here we can find side AE using the law of sines on the triangle AEH. So let me put this here. Find side AE using the law of sines on triangle AEH. And what that would look like, let me just write it out here. So we have two fractions. So we have AE over the sine of GHF. So GHF. And that's equal to EH over sine of EAH. And then we can just put one more step here. I'll call it step 6. And we're going to find side AB using right angle trig on triangle ABE. So we're going to find side AB using right angle right triangle trig on triangle ABE. And what that would look like, we would write, again, the sine DEC over sine ABD and set that equal to the sine of DEC, which equals AB over AE. Okay, on to the next screen. Here we have it says the figure above represents an example of a 4-bar linkage. It consists of 4 bars of fixed length joined in a loop by 4 joints. These linkages are used in mechanical engineering. Number 3, it says suppose that in the figure above, angle BAD is 80 degrees, and the sides are, the length of AB is 30 centimeters, the length of BC is 90, CD's length is 55 centimeters, and the length from A to D is 95 centimeters. Devise a strategy for finding angle ADC. Let me scroll this down, extend the page here. Again. Okay, so what we could do is, if we write these out, first we could connect points B and D. So if we go back up here and just connect these, there we go. Let's put a dotted line in there to show that is what we drew in. And then let's do steps again. We'll do step 1. We could find the diagonal BD using the law of cosines. We could apply that on triangle ABD. And if we do that, we could write that as BD, that quantity squared, equals AB squared plus AD squared minus 2AB times AD times the cosine of BAD. And then we could go to step 2. We want to find an angle ADB. We're going to use the law of sines. And that will be on triangle ABD. We scroll up here, make some more room. And what that would look like, we could write it as the sine of ADB over AB is equal to the sine of BAD over BD. Since AB is not the longest side, that's right. So since the side AB is not the longest side, there we go. Triangle ABD. You know, the angle ADB is acute. So I'll put must be acute. And on to step 3. Next, we want to find the angle BDC. Using the law of cosines on angle BDC. And that would look like this. Cosine BDC is equal to BD squared plus CD squared minus BC squared all over 2BD times CD. Last step. Step 4. We want to find angle ADC. ADC by adding angles ADB and BDC. There we go. And that is the end of this video. Thank you.